So I will skip a few slides every now and then, simply because we have only 15 minutes. And if you have questions about the slides that I skip, please feel free to ask me at the end. So I will focus on the new book that just came out a couple of months ago, also in England. It's called Extraterrestrial. And if I had to summarize it in one sentence, you can see it at the top. When you're not ready to find exceptional things, you will never discover them. I wrote an essay for Scientific American about 6 months ago on this topic. And what you see on the left is a photograph of a picture that was hung on the walls of the Berlin Brandenburg Academy of Science and Humanities 6 months ago in October 2020. And the picture was taken by a photographer named Herlinde Quilbel, who came to my office and asked me to write on the palm of my hand the most important question that we can pose. And I wrote, "Are we alone?" And frankly, I approached this question from a perspective of cosmic modesty. And what I mean by that is, if we look at the universe at large, it's huge relative to our size. We are also around for about 100 years or so, and the universe is 13.8 billion years old. So we only live for one part in 100 million of the age of the universe, cosmic history. And that should bring us some sense of modesty. We are not at the center of the universe, as advocated by Aristotle. Also, what we find in our backyard is very common. About half of the sun-like stars host a planet the size of the Earth, roughly at the same separation. So there are more habitable Earths in the observable volume of the universe than there are grains of sand on all beaches on Earth. And then, therefore, I cannot really understand an emperor or a king like the one shown in this picture, that was very proud of himself after conquering a small piece of land, because that would be equivalent to an ant hugging a single grain of sand on the landscape of a huge beach. There is nothing to be proud of. But I can sort of understand where it's coming from, because when I watched my two daughters, right now they are your age, but when they were infants, they tended to think that the world centers on them. And they were very proud of themselves. They thought that they are the smartest. But when they went to the kindergarten, they met other kids, and then they realized that that's not the case. Of course, they would have liked to stay at home and close the window and maintain their illusion that they are the smartest. But that doesn't change reality. And the only way for us to mature as a civilization is to meet others. We're probably not the sharpest cookies in the jar. And by the jar, I mean our own Milky Way galaxy. And the reason I say that is by looking at the news every morning. We're doing very foolish things. We are fighting each other. We are wasting resources on unconstructive tasks. And the best example, actually, in my book, I discuss Winston Churchill, that in 1939 wrote an essay arguing that we should search for intelligent life out there. He didn't have a chance to publish the essay because he was drafted to become the prime minister and fight the Nazi regime. And of course, the Second World War wasted huge amounts of money, and a lot of people died for no good purpose. It was driven by racism. Just some people trying to feel superior relative to others. Makes no sense whatsoever, given the big picture. And just imagine another world where the same resources that we wasted in the Second World War would have been dedicated to pursue Churchill's vision in this unpublished essay. Perhaps we would have known whether we are the smartest kid on the block or there are others out there by now. And Earth is our home right now, but there are many reasons to worry that it may not be forever. For one thing, the sun will boil off all oceans on Earth within 1 billion years or so. So we need to move somewhere else. And speaking about that, let me just mention a brief summary of my own personal history. I was born on a farm in Israel, 1962, about 59 years ago. And you can see on the second photograph from the left, me collecting eggs every afternoon. We had chicken, and I used to drive the tractor to the hills of the village. You can see it in the middle. Every weekend and read philosophy books. Philosophy was my passion. But I ended up at Harvard as a professor, not through a very typical track. And then on the bottom left, you can see an image of an entrepreneur from Silicon Valley named Yuri Milner that came to my office and asked me to design a mission to visit the nearest star within his lifetime, meaning that the spacecraft needs to get there in about 20 years. And since the nearest star is 4 light years away, it means that light takes 4 years to get there. That required the spacecraft to move at 1/5 of the speed of light, which is 1,000 times bigger than any spacecraft we ever launched with chemical propulsion. So I had to think about it. And this is just a picture of the solar system. You know, there is the sun on the left, and then all the planets. And at 100 times the Earth-Sun separation, you find this region where the wind coming from the sun is stopped by the gas that fills in the void between stars. But then the solar system continues, and most of the volume is so-called the Oort cloud, which includes the building blocks, the bricks that were used in the construction project of the planets in the solar system. And it goes halfway to the nearest star. The nearest star is Proxima Centauri. And it happens to be a dwarf star, 12%, about 1/10 of the mass of the sun. It emits infrared light, and it has a planet that is 20 times closer to it than we are from the sun. And it so happens that that planet has roughly the same temperature as we have on our surface, but it has a permanent day side. It's locked with the same face towards the star at all times. My daughters say that if we ever go there, we should buy a house on the Sunset Strip, which separates the permanent day side from the permanent night side. On that strip, you can see the sunset forever. So how do we get there? Well, the proposal I made to Yuri Milner, this entrepreneur, was to push a sail, a very thin film of material with a very powerful light beam, a laser of 100 gigawatt, shining on it for a few minutes. The sail has roughly the size of a person and weighs less than a gram. And then it can reach within a few minutes 1/5 of the speed of light, and it could carry some electronics with it that you find in a cell phone nowadays. So let me show you a video that illustrates the concept. There are many small laser beams that combine together and shine on the sail that is released from a mother spacecraft above the atmosphere. And the beam shines on the sail for a few minutes. It goes across a distance that is 5 times the distance to the moon. And it heads in the direction of the destination, which is the nearest star system. And then it takes 20 years to reach Proxima Centauri and its planet. And the hope is that it will be able to take a photograph of the planet and tell us what is going on that planet. This would be the first time we exit from the entire solar system. And the challenge, there are many challenges to this project. One of them is to transmit the signal that carries the photograph back to Earth and receive it on Earth, because it will get very faint from a distance of 4 light years away. And so here is the photograph that is being transmitted, hopefully of a planet that has life on it. Then the challenge is to detect the very weak signal, faint signal that we get on Earth. And this project is called the Starshot. And we are currently developing the related technologies involved in this project. The project was announced publicly with Stephen Hawking in New York City. But the real question is, are we the smartest kid on the block? And as I said, I'm not sure, given the way we behave. We're probably not the most intelligent out there. But the best way to find out is by searching. And it turns out there was one object that came from outside the solar system and was noticed in 2017 by a telescope in Hawaii. It was given the name Oumuamua, which means a scout in the Hawaiian language. And you can see the trajectory of this object on the sky. Turns out that it was sort of like a buoy on the surface of the ocean, sitting at rest in the galaxy. And then the solar system bumped into it, just like a giant ship bumping into a buoy, and gave it a kick, so to speak, by its gravitational force. The one peculiar fact about this object is that the amount of sunlight that it reflected changed by a factor of 10 as it was tumbling every 8 hours. And that implied a flat, pancake-shaped object. And also, it also implied a very extreme shape, an object that is at least 10 times longer than wide. And this is, again, the trajectory. There were many unusual properties that this object exhibited, and I call them anomalies. First, we didn't expect such an object based on calculations that I have done a decade earlier. Second, it came from a special frame where it was sort of at rest in the frame of the Milky Way galaxy, and we bumped into it. And then its brightness changed by a factor of 10. It had a flat shape. It was small and shiny, relatively shiny, and it deviated from an orbit shaped by the sun's gravity without showing any evidence for cometary tail, for evaporation of gas from its surface. And so the only explanation for that I could think of was reflection of sunlight. That's what is pushing it away from the sun, in addition to the force of gravity attracting it to the sun. And various people suggested other possible interpretations, but all of them have major flaws, and all of them involve something that we've never seen before. I don't have time to get into the details. I'll be glad to discuss them. But the way I see it is that just like walking on the beach, most of the time you see rocks or seashells that were naturally produced, but every now and then you see a plastic bottle that tells you that a civilization may be out there. There was another object found that also exhibited a push away from the sun by reflecting sunlight without a cometary tail. This one was identified as a rocket booster that we launched in 1966 to the moon. And as a result, we know that this is an artificial object because we produced it. The question is, who produced Oumuamua? And the fundamental question is whether it's natural or artificial. That's the big question. And of course, if we had a picture, if we could resolve it, that would have been fantastic. You can see here an image taken by OSIRIS-REx, which was a mission to get a sample from the asteroid Bennu. And when you get very close to the asteroid, you see that it's made of rocks. And so you can tell that this asteroid is a natural object. But imagine another object that would look like a piece of equipment. They say a picture is worth 1,000 words. In my case, a picture is worth 66,000 words, the number of words in my book. So there are very different ways to detect the signatures of technological civilizations. You can look for example, aside from looking for relics, which I call space archaeology, archaeology in space, you can look for industrial pollution in the atmospheres of planets. You can look for photovoltaic cells on the surfaces of planets. You can look for city lights on the night side of a planet. And to get a sail close to the speed of light, you don't need a laser. You can, in principle, park it close to a star that is about to explode, a massive star. And there is a flash of light when the star explodes. It's called a supernova. Just like surfers on the beaches of Hawaii that are waiting for a giant wave to carry them along, in this case, it's the wave of light that will carry those sails, similar to dandelion seeds that are carried by the wind that you can see on the right here. So there is this fundamental question, where is everybody? That was asked by a famous physicist named Enrico Fermi about 70 years ago. And frankly, I think it's presumptuous of us to believe that aliens will come and have a party in our backyard so that we can see them. I don't think that we are sufficiently interesting for them to pay attention to us. And most likely, they're mostly dead. You know, they came to exist billions of years before us because most of the stars are billions of years older than the sun. And so they might not be around right now. And the best way to look for them is to look for relics that they left behind. I call that space archaeology. And overall, my hope is that by finding relics of other civilizations that perished as a result of misbehaving, as having, for example, not caring about their climate or going into wars, that will convince us or inspire us to get our act together and avoid a similar fate. Thank you. I'll take questions.
Professor Loeb, thank you so much. That was really fascinating. The first question I've got is from somebody in my tutor group, and it's the question about your own personal journey. Why did you began with philosophy? How did you move from philosophy to astronomy? Why have you eventually preferred astronomy to philosophy?
Oh, that was driven completely by circumstances. In Israel, you know, I was mostly interested in intellectual work, in philosophy, asking the big questions. And in Israel, at age 18, you have to serve in the military. It's obligatory. I had no choice. But I had options. I was given the opportunity to join an elite program that allowed me to pursue a PhD eventually, or study in a college at first in physics and mathematics, because they are useful for the defense of the country. And the idea of that program is to qualify people to contribute to technology or industry or the military directly with their knowledge in physics and math. And so I prefer to go to that and have a PhD in physics, and even though it was not my favorite subject at all. And then I developed a project that was funded by the US through the Star Wars initiative of Ronald Reagan. And that brought me to visit the US. And in one of the visits, I went to Princeton, New Jersey, where the Institute for Advanced Study, where Einstein was faculty a long time ago. And they ended up offering me a position under the condition that I'll switch to astrophysics. So I said, okay, I'll switch to astrophysics. It's a very lucrative, I cannot give up on that. And then I was offered a faculty position at Harvard, and I said, oh, I cannot turn that down. And then I was eventually tenured at Harvard. So at that point, I mean, it felt like an arranged marriage, but eventually I realized that I'm married to my true love, because in astrophysics, you can address fundamental questions as you do in philosophy, except with scientific tools. So right now, I'm actually very happy because I have a little bit of an advantage relative to my colleagues, because with my background in philosophy, I have a broader view, and I don't play the same game of that my colleagues play, where they focus on a very narrow niche. So that's how I came to be an astronomer, and it's a very convoluted path. And you know, given the fact that I can imagine a lot of people that have the same qualifications as I do that didn't end up in my place, I'm trying to help young people as much as possible, people from unprivileged backgrounds, or like 80% of my students were women over the past decade. And I'm trying to enhance diversity in STEM, in mathematics and physics. Thank
you so much. This is a more kind of general question. Do you think if we do encounter intelligent life elsewhere in the universe, how will we communicate with other forms of intelligent life? If there's anything that's around now at the same time as us, how will we talk to them?
Well, this is an excellent question. That it has several aspects. One is what language do we use and how to decode their language. You know, it's very similar to code breaking. The military is very interested in that because a lot of time the communication on the other side is done in a way that the meaning is being hidden, and you want to break it to figure out what they're talking about. And so it's the same kind of thing with an alien civilization that uses a different language. You have to figure out what the words are and what the meaning is. But there is also the aspect of how the language is communicated, because for us it's sound waves when we speak, for example, or if we write something, it's the way that the words are getting organized on a piece of paper, and they may use a completely different medium. It may be visual in a way that we are not ready for. I would highly recommend the film Arrival that addresses this issue. It's really fascinating, and I think it will develop into a new discipline of astrolinguistics once we have some contact with an alien civilization. And so perhaps you will be lucky to work in that field.
Thank you very much. You mentioned the science fiction film there. It would be lovely to know what you think. Can sort of science fiction help us by using our imagination to think about what might be out there, or how we might engage with the other civilizations perhaps we come into contact with? Is science fiction any good, or is it just entertainment?
Well, science fiction is good in expanding our imagination, as you said, and imagination is important because it opens up opportunities. If you don't imagine things, you will never discover them. There are many examples that I can give about missed opportunities in science, in physics, just because the physicists couldn't imagine something. You know, and it dates back to the Mayan culture. I visited Chichen Itza in Mexico, and that culture collected huge amount of data about the sky, but they didn't come up with Newton's law of gravity. And so it's extremely important to develop our imagination, because that it allows you to digest the same information in a different way. But at the same time, I don't enjoy science fiction, generally speaking. I enjoy science, and I enjoy fiction much more. The reason most of the books or films do not give me pleasure is because they violate the laws of physics in the storyline. And obviously the authors do that because otherwise the storyline would not be that exciting. You know, if it takes 20 years to reach the nearest star, even moving at a fifth of the speed of light, you can imagine how boring is an interstellar journey. So in a film, you have to make it more exciting, and then you violate the laws of physics. At that point, I cannot enjoy it. So most of the time, most of the Star Trek or other kinds of series or movies, and I've never enjoyed just because they violate the laws of physics, and it strikes me as impossible, unrealistic. Therefore, I cannot have fun looking at it.
Thank you. On that note, another question from Ms. Patel's class is what do you think about UFO sightings? How would you explain reports of UFOs?
Right. So these are unusual phenomena that people report about, and most of the time the reports are either related to eyewitness testimonies or to using equipment that was not really state of the art, not the best to collect that data. And because of that, my proposal is different. I think that if there are any credible reports that come from the military, like let's say the Navy pilots or people on the ships or other places, then what we should do is deploy state-of-the-art cameras. By the way, the cameras nowadays are far better than they used to be decades ago. So we can deploy a lot of them in the same locations and collect data and see if there is anything unusual. Because science is about reproducible results. If someone tells you something, you shouldn't necessarily believe it until you reproduce it yourself. There is this story in the Old Testament, in the Bible, about Abraham that heard the voice of God that told him to sacrifice his only son, Isaac. And if Abraham had a cell phone with a voice memo app, he could have pressed the button and then recorded the conversation, and we would all believe that story. But he didn't have a voice memo app, and therefore we have to decide whether we believe his testimony or not. And that's not a good situation to be in. In science, you want to be able to reproduce the result, or at least have documented evidence from scientific instruments in order to believe it. So that's my take on UFOs. Let's collect better data.
Thank you very much. Do you think if we do encounter intelligent life outside our planet, will it completely change our worldview, our philosophical worldview, our religious worldview? Will it change everything? Will it change everything in those respects for us?
It will definitely have a huge effect on society, because it will change our aspirations for space, the way we view ourselves. Just as my daughters, when they went to the kindergarten, they got a psychological shock from seeing very smart kids out there. So imagine us seeing a piece of technology that is 1 million years into our future. You know, that will be a devastating blow to our ego. You know, we're very proud of the latest edition of the iPhone and all the latest inventions. But imagine a technology that is 1 million years more advanced than what we are using. It will be just like showing a cell phone to a caveman. And of course, the caveman would think that it must be a shiny rock, because the caveman is used to playing just with rocks. So we will have the same response to that. But as you said, there would be also an impact on religious beliefs and on philosophical beliefs and the way we view each other. I should mention an anecdote. Yesterday, there was a cover story that appeared in a Jewish Orthodox magazine, weekly magazine in New York City, and the cover was about my book. So I got a note from a colleague of mine at Harvard that said, well, apparently the Orthodox are not threatened by the existence of the possible existence of intelligent civilizations on another planet. And I replied, yes, it's quite interesting that they are not afraid, but my science colleagues are more orthodox than they are, many of them.
What do you say to your colleagues who don't agree with your interpretation of Oumuamua? How does that work with them?
Yeah, so there were 4 proposals for explaining Oumuamua as a natural object, and all of them suggested something that we have never seen before, like a hydrogen iceberg, a chunk of frozen hydrogen the size of a football field, or frozen nitrogen, or a dust bunny, a collection of dust particles very loosely bound. All kinds of suggestions like that. My point is simple. If it's something that we've never seen before, then why not contemplate also the possibility of an artificial origin, an artificial object, at the same time as we contemplate those, and collect more data, get a photograph of the next object that looks as weird as Oumuamua was. The only way we will not get such a photograph is if we say it's always rocks, if we have a prejudice. And you know, the process of science is all about learning, being open-minded, putting all possibilities on the table, like Sherlock Holmes used to say, and you eliminate one by one, by getting more evidence, you eliminate possibilities, and whatever is left on the table must be the truth. And that's the way we should operate. Unfortunately, my colleagues are trying to remove the artificial possibility from the table without proper evidence for it. And all the suggestions that were made as a substitute invoke something that we've never seen before, and they have major flaws. I don't have time to get into them.
Thank you very much. I've got one final question here, which is, what are your hopes for science in the next 10 years? Where would you like to see, I mean, astronomy in particular, but science more widely, where would you like to see it go?
I would very much like this subject, the search for technological relics in space, to become mainstream. And my hope is that the young generation of today, you, will carry the torch forward and be open-minded and work on this subject, because the public is definitely extremely interested in this subject based on the fact that my book became a bestseller instantly. And the public funds science, and scientists can answer this question. We currently have the instruments, the telescopes to address it. So I think your generation has a good chance of finding the answer, and that would be amazing. I hope it will be in my lifetime. And I told the publisher that I wrote my book primarily to encourage young people to become scientists and find the answer to the question that I pose.
Thank you, Professor Loeb. Thank you very, very much. On that kind of really, really inspiring note, I'd like to thank you so much for joining us today from the United States. It's a very exciting sort of unexpected benefit of all the difficulties we've had with COVID, that we are now in the habit of being able to talk to people across oceans, across continents, and to share scientific ideas in the kind of universal human community of science. So it's been very, very exciting to meet you today. Thank you very, very much indeed. And we hope you have a great, I guess, sort of late morning and afternoon in the US as we all get ready to walk out into the sunshine here at Cheney. So thank you so much.
Well, thank you for hosting me. And I hope anyone that is interested, I hope you will enjoy the book.